Okay, this video is going to go over section 14.1, graphs of sine and cosine. This is the first section of chapter 14 on trigonometric graphs and identities. The first part of the chapter covers graphs, so sine, cosine, and then the next section is tangent, and then the inverse trig functions and their graphs. And then the second half of the chapter is all about identities, which is a pretty exciting part of this chapter. So graphs of sine and cosine, these are what are called periodic functions, and the definition of a periodic function is a function that repeats exactly in regular intervals called cycles. Function that repeats exactly in regular intervals called cycles. So you have a graph, and then at a certain point it starts to repeat, and you have the same graph over and over and over again. So that cycle, the length of that cycle is the period length of the function. So period is length of one cycle. And then the next part of a graph that we'll talk about is the amplitude. Amplitude, in our case, for sine and cosine, is going to be the distance from the middle of the graph to the maximum, or as the book defines it, half the difference between the max and min but as I usually describe it, it's the height or the distance from the middle of the graph to the top or bottom, so the max or min. So it's the height of the graph. It's how it's the distance that it travels, basically from the lowest to the highest point. Well, from the lowest to the highest point, it's half of that distance. It's the distance from the middle to the top or middle to the bottom. So let's take a look at what these graphs look like. I'll graph them first on the graphing calculator and then show you how we get this shape. So let's turn this on, go to y equals, and let's look at sine. So just type in sine of x and hit graph, and we get this wave. It's a sine wave, and so we can see the periodic nature of this. It starts here at 0, goes up, and then it comes back down, and then goes back up again, and then at this point right here it starts to repeat. Now it crosses 0 right here also, but notice when we started, it's crossing 0 and then going up. And so the next time it crosses 0 and is going up, that's when we start to see the period or the function itself start to repeat, and that's the end of the period. So how do we get those points? Well, a lot of it comes from the unit circle. So we're going to draw the graph of sine of x. And let me grab my unit circle here. So our first point we're going to graph is right here when x is 0. So we're finding sine of 0. So that's 0. We're going to use radians here. Sine of 0 radians. Well, 0 radians or 0 degrees is this point right here, right out to the right. It's our starting point when we draw an angle. And the sine value, sine of all these different angles around the unit circle corresponds to the y coordinate. So when we're at 0 degrees or 0 radians, we're looking for the y coordinate, and it's 0. So our very first point is 0, 0, 0. So now let's jump up here to pi over 2, up here at 90 degrees. So pi over 2, When we're at that angle, the y value is 1, so sine of pi over 2 is 1. So what do we got so far? Sine of 0 equals 0. Sine of pi over 2 is 1. So pi over 2 is going to go up to 1. And then when we come back around to pi, it's all the way around here at 180 degrees, sine of pi is 0. And we're back to 0. So we've seen half of the unit circle now. We've gone from 0 degrees all the way to pi. So if you look at the y values, we start at 0, and then we slowly go up until we reach our maximum height, and then it starts to decrease. The y values are decreasing here, going down, getting steeper here as it decreases, all the way to 0. And so on the graph, it looks sort of like a parabola. It increases quickly. That's not the most symmetric of graphs, but you get the idea. It's increasing until you get to your maximum point of 1. That was the maximum value of sine, and then it goes back down to 0. So now let's look at 3 pi over 2. So that's down here at the bottom at 270 degrees. The y value is negative 1. And so we're going to be at negative 1 for 3 pi over 2. And when we reach 2 pi, that's all the way back to the start, 0 degrees. So the y value there is 0. So we draw in our wave, just like that. Now after 2 pi, we would continue around the circle. So let's say I was go all the way around, I'm at 2 pi. Now this point here, this would be like 2.5 pi or 5 pi over 2. Well, now we're back up at 1, and that's going to be this point right here, is back at 1. If we go to 3 pi, that's all the way around the circle, plus another half revolution around to get to basically the same spot as pi, and so we're back to 0. So then it comes back around. So we can see that as we increase these angles, we just continue to rotate around the circle and back around again and back around again. So we keep hitting these same y values, and that's what makes this a periodic function, is because you continue to get the same y values, same output for those different inputs, for the different x values. So I'm going to mark the rest of these points. So notice I'm crossing the x-axis each time we hit a value of pi, a whole number value of pi. And it can go backwards also. If you had negative pi and negative 2 pi, that would just be rotating around the circle clockwise rather than counterclockwise, and you would get the same y values but in reverse. Where am I going? Up here, just like that. Okay, get the right side. Beautiful. So there's our graph of y equals sine of x. So now let's look at cosine. And with cosine on the unit circle, we are talking about the x values. So let's take a peek at our unit circle. X values, let's start at 0. X value is 1. So with cosine, you're starting at 1. Not at the origin, but at 0, 1. That's your first point. So now as we go around, we'll get to pi over 2, and our x value is 0. So pi over 2, we're at 0. When we get to pi, we're at negative 1. When we get to 3 pi over 2, we're at 0. And when we get back to 2 pi, back at the start, we are back to 1. So this is a full cycle here, full period. It looks slightly different than the full period of sine because it starts at 1, goes down, we cross the x-axis, hit negative 1, cross the x-axis again, and then we're back at the top to where we started. But that's one full cycle. Compare that to sine, right? If we block everything else out here, that's one full cycle, that's one period, starting at 0, going all the way to 2 pi. It goes up and then down. In cosine, it starts up at 1, and then it ends at 2 pi, back at the same spot. So let's fill in the rest of this. Got 0, negative 1, 0, positive 1. And then same thing on the other side. We'll cross 0. So we're crossing 0 at these half pi markers. So pi over 2, 3 pi over 2, 5 pi over 2, anywhere that's in between a whole number of pi and 2 pi and 3 pi, all those halfway marks, that's where we're crossing the x-axis. And we're hitting our maximum and minimum points at the values of pi. So 0 pi is a max, 1 pi is a min, 2 pi is a max, 3 pi is a minimum, and it continues with that cycle. So there you go, there's the intro to sine and cosine graphs.